So for example, here, a requirement specification is done. We assume here at this stage that a rigorous process is followed, and what we have in software requirement specification or SRS document, that is good. Now, architecture design, overall high level, and abstract specification, what is needed, translation of the specifications. Then system architecture, right? So architecture design gives us overall system. And here you go to abstract specification, that what we had in terms of system, and see software specifications. So for example, then we can have the different design, say interface design. How would people interact with the system? It's not about how you're writing your algorithm, how you're saving your data, what are your variables, and how you're, what different functions you are executing. No, just the interfaces, user interfaces. So user interface specification. So in requirement specifications, you might not have the decomposed all of these specifications, but in the architecture or abstract specification, you have these, say, user interface. So from user interface, you end up interface specifications. Then component design. So say in the user interface, you have different text boxes, different buttons, or check boxes, or any of the controls that you can have on the user interface or the hardware user interface. Then you design different components of the software that support those user interfaces. For example, if you have 3 buttons and check boxes on the user interface, then you really specify that for every user control that you have on the screen, what people see, then what is the software component or program behind it that you're going to write, and how that software or how that program communicates with other functions or other classes of the software. So component design. And the data structure. Then see, from the user interface, you go to the functions. And when you execute a function or a task or a software program, then what is the data structure? Data structure or data structure design is not only the databases, but if it is an information system, database intensive application, then yes, you do the database design. But here we also look at different variables, different arrays, variables, different types, that what variables you need and how you would use them. And then algorithm design, for example, loops, while loops, or the business process, that how you're going to do. Say if you're calculating temperature, or you're changing temperature from Fahrenheit to centigrade, or vice versa, or if you are changing from say Australian dollars to US dollars, or various business processes depending on what you're designing. So software design process is overall design activities. So look at so architecture, abstract architecture, then interface, component, data structure, algorithm, right? So, but for each of it, it's good that if we have the specifications. So it's not that you have system requirements and you directly design this. No, then see in the specification, do you have system architecture? Do you have software specification? Do you have interface? If not, then we really at this stage specify those designs. All right, so design methods. Overall, we see the design method is, well, you can design, say if it is, before explaining the design method, say if you're designing a software looking at the requirement specification, you can use your own method. There's no problem if it is a smaller software, but here we are talking about larger softwares. So this is what we have in the design activities, is really a systematic way of doing the design. Otherwise, if you just interchange or do certain things first, say you write your algorithm, then you create the user interfaces or overlap these activities. If smaller project, manageable, you can do it. but larger or systematic way that if you do something, others can understand. So it's really a systematic approach to develop the software design. So overall, we when we design a software, maybe as a developer you design it, or as an analyst you do your requirements, you understand it. But it's really difficult if others don't understand, so we document them using natural language and graphical models. So possible models, for example, for the graphical models can be data flow models, entity relationship attribute model in data, or structural models, or object models. We look at them now. Now in specification, in requirement specification, we also have to have the acceptance test, for example, system integration or subsystem integration test. We are not discussing more detail on the testing, that we have a advanced unit for that we'll do later. But here in the requirement specification document, or we really have to create the further sub processes that initially we conduct the acceptance test. If whatever your system does, is that what users needed? So you do that before doing the system integration. So system integration, where you create really your small systems in the software, then how they do work, though you have them in the design, but how they work when you put them in practice, right? So testing it, not just creating it, but testing is where we create the test cases, and I'm just trying to explain what is testing and how we do it. So when you write a computer program or a software, then you might think that it works properly, right? That's fine for smaller programs. In the larger softwares, when you have different functions, that sometimes there is a possibility that your program might have some, not the syntax error, but some logical error. So for example, if you're calculating the square root of the number, so you write your program, and someone else or the tester should create a test case that what is the input and what is the expected output, and execute your program before delivery, before you do it. Similarly here, system integration, smaller subsystems, you test them and then you deliver them.
The Victorian Institute of Technology has other great videos covering many different topics. Please check them out, and thanks for watching. Remember to like and subscribe the video for more great content like this.